Greetings, ladies and gentlemen. Going over the homework, systems of three equations. We're on page, I don't know, 76, I think. And we're looking at problem 9. So I've got three equations here, and the goal that we had, like a mathematician on a desert island, is to reduce my problem into one that I already know how to solve. So I'm going to do that by eliminating or solving, substituting the same variable twice. Now, if we chose to use substitution, good targets would have been here, 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 or here. Those are all pretty good targets. The best ones are obviously the first equation z or the third equation x, because they're positive, but these other negative ones aren't bad at all either. So if you were to solve by substitution, a basic thing you would do is say like solve for this z, you'd get an expression z equals, it would end up being negative 7x minus 5y, and then you would take that and plug it into both of the other equations z's. All right? And by doing so, you'd have two equations that were written all in terms of x's and y's. Okay? So that's the substitution route. Let's analyze the elimination route just in case. If I was getting opposite x's, the LCD between all of those is 7. For the y's, 5, 3, and 6, I think is 30, if I'm not mistaken. And for z's, it looks like it's 2. So I'm going to label these. Actually, I'm going to even label them different than we did yesterday. I'll use A, B, and C for my equation names. So if I want opposite z's, for the first equation, what would I multiply that by? 2. So I'll figure out what 2a is. And equation B already has a 2 there, so that's fine. And equation C has a negative, so that's nice. But I would need to still get this to be a negative 2z, so what would I multiply that by? 2. So I'm going to figure out what 2a and 2c are. That's my first kind of start here. So 2a would be 14x plus 10y plus 2z. 2z. And c, doubling it, would be 2x minus, 6 times 2 is not 8. That's minus 12y minus 2z equals negative 36. I almost forgot to double that. That's a common mistake. So that's a huge place to look, is when you're multiplying your equations, making sure that you actually multiply the entire thing, as in both sides, if possible, right? So now that I have these, I'm interested in using this, this, and this to eliminate 2 z's in 2 of the equations. So it looks like I'm going to have to use this one because it's the opposite, so I'd use this one twice. So I'm going to end up doing, looks like I could do, what? I could do b plus 2c. Sounds like a good combination, right? That would eliminate this, and this would eliminate, right? And then what would I add to equation 2a to eliminate? The z, right? So yeah, so I'll do 2a plus 2c. Right, so I'm just kind of trying to outline my process in advance so I kind of know what I'm doing. So having some sort of labeling mechanism is really important for this, because otherwise you'll have no idea where the work is coming from, and it'll take a lot of trial and error to figure it out. So let's see, b plus 2c. So I've got negative x plus 2x is x. 3y and negative 12y is negative 9y. 2z and negative 2z is 0. That's exactly what I wanted. And 16 and negative 36, I believe, is negative 20. I think, yeah. Right? And now for these two, it looks like I can just add these two. They're nice and side by side. So that's 16x minus 2y equals negative 36. And notice what I've done. I've reduced this to a system of 2 equations and 2 variables. I know how to do that, right? That's great. And let's see, I might even give these new names. D and E maybe, just to simplify things. I don't know. So looking at those, I could now solve, I don't know. I might use just substitution on this one, just because I feel like it, but it doesn't matter. I'll commit to elimination. Why not? I've gotten this far, haven't I? So for opposite x's, that'd be 16. For opposite y's, it'd be 18, right, between 9 and 2. So I'll go for the opposite x's. So in order to get opposite x's, what should I multiply equation d by? Negative 16, even better. Negative 16 times equation d will get me a opposite x there, right? So let's do so. So that'd be negative 16x. Let's see, 16 times 9. Ooh, catch this here. Watch this. Let's see, 16 times 9 is the same as 16 times 10 minus 1. This is how I do math in my head, by the way. And then, so that's 160 minus 16. And so that's going to be, what, 144, is it? Isn't that cool? 16 is a perfect square, and 9 is a perfect square. They happen to multiply to be a perfect square. I guess that makes sense. Yeah. Yeah. I don't think you could have that happen. Yeah, of course. There's no other way that would happen. So, okay. I guess it's not as cool as I thought, but I was happy with it. And let's see. I was multiplying a negative by a negative, so that's going to be a positive 144 y equals, and then 16 times 20. This one's also going to be positive 320, if I'm not mistaken. And now I can combine, what am I combining? I'm combining equation E with this negative 16D, right? Because what did I get? I got my opposite x's, which is what I wanted. So add them up sort of thing. So this is going to be 142y equals 16 less 284. And that looks very halfy in my mind. Divide both sides by 142. And I think y equals 2. Can someone confirm that y equals 2 is the correct portion of the answer so far? Okay, I got some head nods. Nice. So, cha-ching. And I've still got to find x and a z. So where should I plug this to find one of those? Equation C? C has 3 variables, so plugging it in there wouldn't help me find another one yet. Equation D would work, E would work, or even negative 16D would work. Any equation that has only 2 variables, preferably one of them being the one that I already know. I happen to like equation D myself because the x is just kind of like a little positive one there, just to explain my logic for choosing it, right? So I'll have x minus 9 times 2 equals negative 20. Actually, I could even figure out a cool label system for this. I could call this D of 2. No. Technically, it's D of x comma 2. I don't know. I guess that's not as cool as I thought. Well, I'm plugging in y equals 2 for D. I don't know. I thought I had a cool labeling system. I suppose I could really develop it if I wanted to, but there's no standardized system for that, I suppose. Yeah, probably x comma 2 comma z would work or something. I don't know. But anyways, whatever. That's not important. And then I think I can add 18 to both sides. Is this going to be the right answer? Okay, we're on a roll. And now what should I do with how to find z? Well, why wouldn't I plug it into D? Look at D again. Because there's no z in there. So I could plug it into A, B, or C. Heck, I could actually even plug it into 2A or 2C if I wanted. So I'm trying to find Z. What do you think is the best one to plug it into? A. Yeah, it looks like A because Z has just got like a regular old thing there. So I'm plugging this in this way. Let's see if my arrow can come down nicely with a nice curve connecting it. And one of these. Right? So actually drawing these lines can be really helpful. I know it makes your work kind of look a little sloppy, but I actually really recommend it. So let's see, I'm plugging in for 7x plus 5y plus z equals 0. So 7 times x plus 5 times y plus z equals 0. And so that's negative 14 plus 10 plus z equals 0. Negative 4 plus z, that's a weird z, z equals 0. And I'm going to end up with z equals 4 when I add my 4 to both sides, right? Blam, blam. So my answer as an ordered triple would be negative 2, comma 2, comma 4. By the way, I don't know if you know this, but ordered pairs typically come in alphabetic order. Just so you know. So ABC, stuff like that. The only time that I've not seen that is when they're user-defined variables. Like you could, for instance, have your your x-axis be time and your y-axis be, I don't know, height or something like that. And in that case, t comes before h. But typically, if they're just some random variable names like this, it's alphabetic. That's what you end up doing. So there we go. Let's look at this next problem, and I'm only going to take this halfway. Let's see, I did the previous one by elimination. This one I'll do by substitution, just so we see both in work here. So here's some weak spots for substitution. There's 2 good targets. What would you guys rather me target, x or z?
X.
All right, let's do x. All right, so I'll even label these again. Let's see. Man, my cursor is a little bit hard to see at times. So let's solve equation B for x. So I've got x minus 3y minus 2z equals negative 8. Let's just move everybody over. Move over. So I'd get x equals 3y plus 2z minus 8. And that's going to be my revised equation, right? So I could call this B revised, maybe. I don't know. Sounds like a good label. And what can I do with this? Right, I have to plug it into the other equations. So I'm going to plug it in for equation A's x and in equation C's x. And by doing so, I'm going to kill the x's in both of those cases because I'm replacing them with something that's written in terms of y's and z's. Okay? So that's the goal. Eliminate the same variable twice. Right? So here we go. So let's do that. So 3 times 3y plus 2z minus 8 minus 5y plus z equals 9. Oftentimes after you finish writing this part, you'll forget to end up including these guys over here. Let's see, I'm erasing all sorts of weird stuff today. And for the other one, I'd have 5 times that expression, 3y plus 2z minus 8 minus 6y plus 3z equals 15. And now I've got, I don't know if you realize it yet, but I have a system of 2 equations and 2 unknowns. Because these are all y's and z's. And we know how to solve this. I just probably could simplify this a little bit. So triple distribution, like so. Let's simplify the top one. I'd have 9y plus 6z minus 24 minus 5y plus z equals 9. I guess I'll keep simplifying this one. Combining some like terms, I've got some y's that can hang out. I've got some z's that can hang out. And I could add 24 to both sides, am I right? So let's see. For the y's, I've got 4y. For the z's, I've got 7z. Oh, that would have been my first error. And then I would have messed up the whole problem. So here's one good equation. I like it. Now let's go back to this guy and simplify it down here. So 15y plus 10z minus 40 minus 6y plus 3z equals 15. And whew, this video is getting long. These problems take a while. So combine those, combine those. Let's move 40 to the other side. And we have, let's see, 90 plus 13s equals 55. So between this equation and this equation, hopefully you could solve from there. I would use elimination. Actually, I'll even rewrite this top one here. 4y plus 7z equals 33. And if I was to do that, the LCD between the y's would have been 36. Yep. And between the z's, that's a 13 and a 7. Oh, those are both prime. They're not even just relatively prime to one another. So 7 times 10 is 70 plus 21, 91. So I would have probably gone through and multiplied this one by 4 and this one by -9, right? Yeah. And gone from there. But I'm going to leave that up to you guys. So goodbye, Internet. This video is long enough. Hopefully you learned some stuff.